So what is software engineering? It is an approach to develop software. Building construction analogy through some systematic collection of past experience like techniques, methodologies and guidelines. So before going to software engineering, I am asking you that what is a program? The program is a set of instructions written in a programming language used to execute for a specific task or particular function. Okay, so a program does not have further categories. A program is a simple or set of instructions written in some programming language, and it is obviously flexible. A program cannot be a software. A program is not a software. Now what is software? A software is a set of program written in some programming language. The programs are written in some programming language, and a software is a set of programs. So it should be executed for some specific task. A software is execute for some specific task. So normally we can say the software can be categorized in two way, that is application software or system software, but we cannot categorize a program in further two way. And a software is a combination of different programs. Software can you can move from one place to another place. You can move the software easily, not easily than the program, and software may not be machine dependent, but program may be or may not be also. A program consists of set of instructions, which are coded into programming language like C, C++, PHP, Java, but the software consists of bundles of programs and data files. Programs in specific software use these data files performs a dedicated type of task. Now, what is system? A system can be defined as a collection of components. A system can be defined as a collection of components that work together to materialize an object. So that is, a man performs a breathing process or managing his breathing process is obviously a system. So a system is a collection of components that work together to materialize an object. So what is information system? A system that provides information to people in an organization. A system that provides information to the people in an organization, that is called the information system. So a system that provides information, for example, it is a payroll system, it may be a payroll system or an enterprise system. Now, what is system analysis? System analysis is an important activity that takes place when the information system is built or existing in change of modified. So system analysis is an important thing when we like to modify our system or we are going to create a system. So this software engineering is an approach to how to modify an existing system or how to create a new system. We need to learn this approach because this approach gives us a better way to implement the software implement a software. So we have to learn this systematic way. If it is not to be systematic, if it is should not be it should be random, then we cannot organizing the software in a better manner or organized manner. Okay, so this is the IEEE definition. Software engineering is the application of a systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. So, software engineering is an application of a systematic, disciplined, and quantifiable approach. That is implemented to develop the operation and maintenance of a software. So, what are the software crises? It is often the case that software products fail to meet user requirements. If the software fails after some day or after some years of preparing the software, it fails to meet the user requirement, then it is a software crisis. If it is too expensive, then obviously it is a software crisis. If it is difficult to alter, debug, and enhance after some days after preparing the software, a new requirement may come and we need to alter or we need to debug due to an error, or you need to enhance our software for better performance. Then if we do not do this, then it is a difficulties. It is a software crisis. Often delivered late, it is obviously a software crisis. Suppose you are saying that this software will be delivered within 1 month, but after 6 months you are not finishing the work, then it is a crisis. And use resources not non-optimally. That means you have so many resources, but you are not using them optimally. That means you are working some resources one time and other resources are waiting. Some employees are working on your software and some employees are working to finish that work. So this is not use of optimal use of your employees or your resources. So these are the software crises. Anybody, you may heard that there was a problem Y2K, that was the software crisis, but the crisis has been overlooked has been solved by our software engineer. Y2K means when year 2000. Y2K means year 2000. In year 2000, before the year 2000, all the years are stored into two-digit number, last two-digit number of year. That is, if it is 1998, then 98 is stored as a date into the computer. So this year, if it is 2000, then 202 is stored into the place of year. So showing this 200, we cannot understand that it is 1900 or 2000 or 2100, etc., etc. So this was the problem in year 2000, year 2 Y2K problem, and after that this year has been resolved and has been stored by 4 digit. So this was the software crisis. So which factors are contributing to the software crisis? The factors that makes the software crisis are larger problems. If the problem is a very big problem, that it is not cannot be handled very easily, so the software becomes into the crisis. So next is poor project management. A poor project management makes your software into crisis. Lack of adequate training in software engineering. If your employee has not good training, and they do not implement your software right way, then obviously your software becomes into a crisis. Increasing skill shortage. The same thing, if your employee's skill is not good into some area, then if he like to implement that software, then it is a problem. Low productivity improvements. If productivity of your software is very less, then it will becomes a software crisis, obviously. But that means in that case your software will not finish into that time, and the user the uh, uh, the man or the user who give you the project, he may be very angry to you, and may refuse to take the software from you, and obviously it is a software crisis. So then the next is, what is exploratory software development? In early, before the software engineering has been introduced, in early programmers use this exploratory style. Also, it is called build and fix style. Okay, early programmers use exploratory style, and also it is called build and fix style. And a dirty program is quickly developed, then bugs are fixed as and when they are noticed, similar to how a junior student develops programs. So a dirty program first has been introduced, and suppose I am giving you to prepare a software. You first prepare a program. You have first write a program and then checks bugs. What are the bugs are available? I am checking you, and or your friends checking you your software and say that this is the problem, this is the problem, this is the problems, and you are fixing the problems. And this is the actually the exploratory style. And your my student life projects are normally are doing this. Suppose I am asking you to prepare a software X, to prepare a suppose calculator, and I am giving you the time, suppose 3 months, and the same project I am giving into a software company with the same employee, same infrastructure, same resources, then obviously they will take more than 3 months if the software prepared by you into the 3 months. So why the company will take the more time than the software prepared by the student? Because the student software generally not used for solving any real problem. They do not think any, they do not have any organizational structure. The industrial software have huge impact in terms of financial or business or loss of property or life. But in the student life, these type of ideas cannot occur into our mind. Also, the industry software needs to be of high quality of with respect to properties like dependency, reliability, user friendliness, etc., etc., etc. And for this, a required region testing of 30% or to 50% has been infused into the student. That means the testing of the software of an industry built software is very much better than the student prepared software. Okay, and the software has been the software has been prototype properties which does not exist in student software, and that means all the properties may not be available into the student software, but it should be available into the industry. And this industry, in case of student, they may not be take the requirement analysis of the software to go by physically going into the actual existing steps places, but the industry will take a requirement specification by physically going into the actual system, and they will prepare a SRS, software requirement specification, in that case. And this is the exploratory style. Before the software engineering, this type of software, the software is built this by using this structure. At the first time, the initial coding has been occurred, and then test there is any bug or not, and then it fix it, and again test it, again fix it, until or unless the software has been prepared. So what is the wrong in this exploratory style? Besides the exponential growth of effort, cost, and time, and the size of the problem, the exploratory style usually results in unmaintainable code. If the code becomes day by day larger, test fix, then these codes become larger day by day, and the link between these codes has not been established a proper manner. So the effort becomes day by day larger, the cost becomes increasing, and obviously time becomes increasing. And obviously in the another case, the software quality becomes less day by day, because the modularity of the software has not been done, the functionality of the software is not done proper way, and reusable of code is not done in that case. So it became very difficult to use the exploratory style in team development environment. So in case of team development environment, and all of the teams are doing initial coding, all of team are testing, fixing. This is a very critical process. Why study software engineering? To acquire skill to develop large problems. So to handle this type of problems, we need to skill how to develop our software, in which manner, in which way. So handling exponential growth in complexity with size, that means the software is growing day by day, so software size becomes larger, and we need to handle this software size day by day, and we need to acquire, develop the large program. The systematic techniques based on abstraction modeling and decomposition. So we have got a big problem, and we need to solve this big problem by our software engineering approach. So in this approach, first we have to decompose the whole program into the some model, into some module, and then we have to decompose this module step by step into some similar 2 to 10 line of functionalities, and this functionality will be developed by our employees. Then we integrate all the modules and we will prepare our software. So this is the one of the systematic technique of software engineering. We learned systematic technique because specification, design, user interface, development, testing, project management, maintenance, etc. These are the parts of your software engineering. How to specify your software, how that all of users, all of stakeholders of that software can understand that what is the actual specification and do accordingly their design, coding, testing, etc. So then the design part, you have to design such a way that all of the user can understand what is the design. Then the user interface development, it should be good, friendly and user friendly. And then the testing, obviously the major part of the software engineering is the testing. It will take a maximum time of development, the software engineering, and this testing should be in proper way, and everything depends on the testing. All of the ways you have to test it. Then the project management actually to manage how long the project is going on, and how part of this project is completed till now. And then the maintenance, you know that a software never ends its life. That means a software never becomes useless and you throw it. The software never retires actually. The software, you may change your requirements into the software, you add your requirements into the software, and the software will work accordingly. So the maintenance is an important part after installing the software into your different stations. So suppose if you go any bank, then there are in a site into the bank there is a room that is called server rooms, and in that place there is a there are some maintenance person who is maintaining those servers, who is updating those servers from one server data to another data, and that is the task of maintenance. Each and every day the maintenance is working into some bank. And next is the software engineering will acquire skills to better programmer. It will give you the high productivity and better quality programs. High productivity and better quality programs. And quality means what? Quality means the quality is the characteristic or attribute of something. So to acquire high quality, we need to check the functionality of the software, that all the functionality works fine or not. We have to check that the software is reliable or not. We have to check that the software is usable or not. That means user can use the software and be benefited or not. And we have to check the efficiency of the software. That means the software is efficient in all aspect of the user needs or not. Suppose in some big billion day, Amazon or Flipkart give some offers to the customers, and previously in the Flipkart servers becomes crashed down in that day. Why? Because a heavy load of users may not be efficient for that software. So that software should be efficient to handle all these aspects. So you have to imagine in that case that how much load may be put on your software, or your server or your hardware may able to handle that load or not. So this is one of the example of efficiency. Then the maintainability means they make the corrections after some days, or after the adaptation of the software is possible or not. And then the portability means you can easily move the software from here to there or not. That means you can download the one example is you can easily download your software into your system and install it. Another is you can make this software into a CD or DVD, etc., and install it. This is the easy example of portability. And this if the software functionality, reliability, usability, efficiency, maintainability and portability is good, then your software is a high quality or high quality software. And in case of high productivity, if the software becomes very less time to acquire the software preparation, then it should be high productivity. And we have got the two types of actually software products are there. One is product based, another is service based. What is product based? Product based is general software. Suppose I have a software company and I would like to prepare a game, or I like to prepare a such type of software which may be use any type of persons. Suppose I am preparing a calculator. The calculator may be use any type of person. So nobody give me the project, and this is a generic project, and anybody can use or buy this from me. So this is the one type of generic project. A game is a generic project. If nobody give you to prepare a game, okay, give you the assignment to prepare a game. And another is service. That means customer gives you the order, what is his requirement, that is, and you prepare the software according to this custom requirement. So this is called service oriented software and product oriented software. Okay. Emergence of software engineering techniques. In early computer programming in 1950s, the programs were being written in assembly code. You know all this, and the size limited to about a few hundreds of lines of assembly line of code. So then that time the software was into 100 lines of assembly code. In early computer, every programmer developed the software in his own style, in his own writing program, according to his intuition, called exploratory or built-in fixed program. In early 50s, there is no software engineering approach, and a single programmer can use this into a single programmer prepare the software in a single way. Then in early 60s, the high-level programming language such as Fortran, Algol, COBOL were introduced, and this reduced the software development effort greatly. Only they reduced the software development effort by writing these softwares into the assembly code. Then the software development style was still exploratory. That means the typical program size was limited to few thousand of lines of code. So the typical program size were limited to a few thousand of lines of source codes, and as the program size has been increases, program size has been decreases in the case of Fortran, Algo or these high level languages, but the software development style has not been changed. The typical programmer make the software in that previously built in fixed style. Then the size of complexity in control flow based design has been introduced, and the size and the complexity of the programs increases further. The exploratory programming style proved to be insufficient in that case. The programmers found very difficult to write cost effective and correct programs, very difficult to understand and maintain programs written by others, and flowchart technique was being developed. Actually, after at the late 60s, the condition based, or you may say if else based if else based has been introduced to increase the program complexity, that increase the program complexity, but it is a better way to implement your software project, and it should be very cost effective and correct programs. And before this late 60s, it was used into the program like goto. You have to use the goto into the goto. If you use goto, then the flowchart, if you draw a flowchart using the goto program, then it should be a hazy program, and lots of complexity comes into the program. But if you use if else or switch type of conditional statements into your program, then your programs becomes a clear program, and you will better understand this program by using this if else condition. So before the late 60s, it was used the goto program, but nowadays it is used the if else condition at the late of 60s. So the flowchart technique also has been developed in that time to show the flow of your program. Then it comes the structured program. A program is called structured if into that program there is a sequence, selection and iteration. Sequence means instructions one by one. It was at the early 50s, like in assembly code. It was in the 60s in the Fortran or etc type of code, COBOL etc type of code, and then it is the selection at the lates of Fortran sorry, and then it comes to the iteration after the 60s. Iteration means it is a loop. The loop has been introduced, and when the loop, selection and sequence are introduced, all are introduced, then the program becomes a structured program. We call it as a structured program. And obviously it consists of modules. Modules means function also be introduced in this structured program. Each and every function we can say that it is a module. We may say that it is a module. A module consists of a single function module. Okay, no problem. But a module may be consist of more than one function. No problem. So what is the structured programs? It is easier to read and understand. It is easier to maintain, require less effort and time for development, and it is less buggy as it is structured. So you prepare your software using the less effort and less time. That means multiple employees can work into a single project, and seeing different as it is moduled. So different module may work parallelly, may grow parallelly, and it should be less buggy, that each and every module are working on different employees. So this is the structured program. What we are still using this type of program into our software. And then in early 70s, data structure oriented design has been introduced. A program size increased further. Soon it was discovered it is important to pay more attention to the design of data structure of a program than to design of its control structure. Okay, so control structure has been developed, iteration, selection, everything has been developed, and now the thinking is to the important thinking is to more attention, give the attention more into the data structure of the program, how to structure your data into the program. So data structure has been introduced in the early 70s. So this is the actual factors that dependent for high quality and high productivity of software. You need for a good quality or high quality or high productivity, you need good technology, good process and good people. Good people means if your employees are well trained, they have well idea to develop that type of software, that means they are experienced, then your quality of the software should be increased. High process, that means if you use better or best algorithms into your software, then obviously your software quality should be high, your complexity becomes less. And then the technology, if you use highest technology like Java, etc., Python, etc., this type of technology, then the complexity of your software becomes less, and this is called the iron triangle. So these three factors helps good technology, good process or methods, and good properly trained people. So these three factors helps you to better quality and productivity of your software. Thank you.